Our eighth presenter is Lara Abdelmohsen. Lara's presentation is The Brain's Roundabout, Understanding Stroke in Adults with Sickle Cell Disease.
Today, I will be introducing you to a very important group of blood vessels that come together to form an anatomy called the circle of Willis. The circle of Willis is the primary pathway that allows blood from your heart to reach your brain, and its unique circular shape allows it to protect our brain from stroke. To understand how it does this, we can think of it like a big roundabout. So, for example, traffic and construction in Oakland. If Forbes Avenue is blocked, they can reroute cars to Fifth Avenue or a different street, right? Similarly, if one blood vessel in the circle of Willis is blocked, blood can be rerouted through another vessel to continue supplying the brain with energy and nutrients. But what happens if this rerouting mechanism is no longer efficient? This is what we see happening in patients with sickle cell disease, where red blood cells change shape from a circular, flexible shape to a more curved and rigid shape. This causes them to clump together and block blood flow, leading to stroke. Now, life-changing progress has been made when it comes to protecting or predicting stroke risk in children with sickle cell disease. Let's take a patient called Erica, for example. She goes to see the doctor. The doctor will take an ultrasound probe and place it on her forehead to measure how fast blood in the circle of Willis is flowing. If it is flowing very fast, that means Erica is at a high risk of stroke, and treatment guidelines are implemented immediately. But with this intervention, Erica can now live past 15 years of age. But what happens when Erica goes into adult years, like 20s or 30s? She goes to the doctor. They can no longer predict whether Erica will be having a stroke, even though there's a 60% chance she gets a stroke in adulthood. And why is that? Why can't we use ultrasound? Because ultrasound waves can't penetrate through our skulls. As we get older, our skulls become thicker. So then, how do we understand why adults with sickle cell disease are getting stroke? This is where my work comes in, where I take patient data and MRI images of blood vessels in the brain, and I use them to build mathematical models that allow us to simulate how blood is moving through the circle of Willis. These models are not general. They are patient-specific, and through these models, we have found differences in blood flow patterns and blood pressure in the brain of up to 70% when we compared adults who have stroke and adults with sickle cell disease who don't have stroke. This is a big contribution because if we want to protect this understudied population from stroke, we need adult-specific models that are non-invasive, patient-specific, and more reliable than ultrasound so that we can lay the foundation that future diagnostic and therapeutic tools depend on. Thank you very much.